square, that is 4 cos square theta. Okay, now here is a double integration f and ds, that is equal to double integration 1 by 2. Put this value f dot n, here we are putting this value, and this is our ds, 4 sin theta d theta d phi. Okay, now we have to integrate this term, this whole term. So first of all, simplify this term with some manner so that we can easily find to integration. So this is 0 to pi, right, because our limit is 0 to pi for the theta, and this is 0 to 2 pi. 56 cos square 5 sin cube theta minus 8 cos square theta sin theta d theta d phi. Now 0 to 2 pi, first of all integration with respect to theta. So you will get, when 0 to pi is from sin cube theta, but sin is an odd function, so we are here using some theorem. So 0 to pi sin cube theta d theta, that will become 2 0 to pi by 2 sin cube theta d theta, using one important theorem which you already studied in the 12th standard, some property of the integration, right. So 2 0 to pi by 2 sin cube theta d theta minus 8, the integration of cos square theta sin theta. Now we know that integration of f dash x into fx, that is equal to fx into f dash x, integration of fx into f dash x, that is equal to fx square divided by 2. Okay, in general, integration of fx raised to n into f dash x, that will become fx raised to n plus 1 upon n plus 1, integration of that part. So we are using that formula because the derivative of cos theta is minus sin theta, clear, but here only sin theta. So we are multiplying with minus 1, right, minus sin theta, and here divided by minus 1. So you will get integration of cos square theta sin theta, you will get minus cos cube theta divided by 3. Integration is from 0 to pi. Put that value, right. Similarly, integration of sin cube theta, okay, and 0 to pi by 2. So you will get 112 cos square 5 into 2 by 3. Here this formula is coming from the reduction formula, right, 0 to pi by 2 sin cube theta. Okay, so that is 3 2, right, and into 1, so 2 by 3 minus 8 into 2 by 3. Put the value of pi, cos square pi, we know that cos pi is minus 1, so minus 1 cube into minus 1, so you will get 1 by 3, right, and minus plus 1 by 3, 1 by 3 plus 1 by 3, you will get 2 by 3, 8 into 2 by 3, right, so d5. And then this is some numerical illustration that you have to understand, that how to find the integration of this terms. Okay, so 112 into 2, that is 224 divided by 3, and this is integration with respect to 5. So you will get cos square 5, we know that 1 plus cos 25 divided by 2 minus this is 16 by 3, integration of 1, that is 5, 0 to 2 pi, and now put the value of 2 pi here, so you will get 2 pi, right, and then integration of 1 plus cos 25 divided by 2, you will get 5 plus sin 25 divided by 2 from integration from 0 to 2 pi. Put the value of 2 pi, so finally you will get 112 divided by 3 into 2 pi minus 3 square divided by 3 into pi. Okay, so this is also 64 pi, you will get 64 pi. Okay, so both the part, you can see the first part we find this part, right hand side part, that is also 64 into pi, and this part, that is also 64 pi, that you will get. Okay, so the divergence theorem we verified. Next question, question 2a, second part. Find the directional derivative of f of xyz, that is equal to xyz at the point minus 1 1 3, in the direction of the vector I minus 2j plus 2k. We have f is equal to xyz directional of the function f, that is the derivative of this function with respect to x, that is yz into I, the derivative of this function with respect to y, that is xz into j, plus the derivative of this function with respect to z, that is xy k, at the point 1 minus 1 1 3, that is equal to directional of the function, that is 3i minus 3j minus k. Okay, put the value of x y z, instead of x y z put the value of minus 1 1 3, that is you will get 1 into 3 3i, right, then x into j, so that is minus 1 into 3, you will get minus 3j plus 1 into xyk, so 1 minus 1 into xy, so that is minus 1 into 1, so you will get minus 1k. Clear? Now a is equal to I minus 2j plus 2k, so a caret, that is I minus 2j plus 2k divided by its norm. What is its norm? Under root 1 plus 4 plus 4, so under root 9, so that is 3. Okay, and required directional derivative, that is the dot product of directional of f dot a, that is dot product of this two term. So 3 into 1 3, then minus 3 into minus 2 plus 6, and then minus 1 into 2 minus 2, so 3 plus 6 minus 2 divided by 3, because this is 1 by 3 here, so 3 plus 6 minus 2 divided by 3, so you will get 7 by 3. Finally 6 plus 3 9 minus 2, that is equal to 7 by 3. Okay, so here the complete this solution of this question, question 2a. Next question, question 2a, question 2c, sorry, question 2b. Find the inverse of the matrix A of the 3 cross 3 matrix 1 2 3 2 5 3 1 0 8. The first row is 1 2 3, second row is 2 5 3, and the third row is 1 0 8, using row operations. Row operations means we have to convert left hand side, we are writing the same matrix which we have, which we want to find the inverse of that matrix, and the right hand side we are written identity matrix. Okay, now using the row operations I want left side identity matrix. Okay, that means using some row operations, after all finally we will get the identity matrix is left hand side, and whatever the matrix in right hand side, that is exactly our inverse of the given matrix. Okay, so let's see how to solve this example. So this is our given matrix 1 2 3 2 5 3 1 0 8, and this is our identity matrix 1 0 0 0 1 0 0 0 1. Okay, now we are multiplying first row with minus 2 and add into the second row, that is so 2 minus 2 0, 5 minus 4, that is 1, 3 minus 6, that is minus 3, then 0 minus 2 minus 2, 1 minus 0 into 2, that is 1, and 0 minus 0, 0 minus 2 into 0, so you will get 0. Okay, so this is our first process, that we are multiplying first row with minus 2 and add into the second row. Now also I want 0 here, right, because to make a identity matrix, so we are multiplying first row with minus 1 and add into the third row. The next process, that is 1 minus 1 0, then 0 minus 2 minus 2, then 8 minus 3 5, 0 minus 1, you will get minus 1, and 0 minus 0 0, 1 minus 0 1. Clear? Now this is our given matrix. Next matrix, now also pick up the second row, this is our leading entry, correct? I want 0 here and also 0 here. So what we have to do, we are multiplying second row with minus 2 and add into the first row, and multiplying second row with 2 and add into the third row. So first of all, first of all we are multiplying second row with minus 2 and add into the first row, correct? So what is the, now our first row become, this is 1, then 2 minus 2, this is 0, then 3 minus 2 into minus 3, so that is 3 plus 6, 9, okay, so this is 109, correct? Now 1, then 1 minus 2 into minus 2, so that is 1 plus 4, so you will get 5, correct? Then 0 minus 1 into 2, so that is minus 2, and then 0 minus 2 into 0, so you will get 0, correct? So now you can understand how we, first row is coming from 109, 5 minus 2, 0, second row is as it is. Now our next process is, we are multiplying second row with 2 and add into the third row. So we are multiplying second row with 2 and add into the we are multiplying second row with 2 and add into the third row. So this third row become now 0, then this is 0, then minus 6 plus 5, that is minus 1, then minus 4 minus 1, minus 5, then 2 plus 0, 2, and this is 0 into 2 plus 1, so 1. So here is the answer, 0, 0, 0, minus 1, minus 5, 2, 1, correct? Now you can see left hand side, in the first column this is 1, below that 1 we have 0, in the second row this is a leading entry, below that leading entry and above that leading entry, now also we have 0. Now this is minus 1, okay. So first of all, either we are convert this minus 1 is 1 and then make 0 here, or just directly we are multiplying third row with 9 and add into the first row, correct? Add into the first row. So the first row become, you can see 1, 0, 0, then we are multiplying third row with 9, so minus 5 into 9, minus 45 plus 5, so you will get 40, minus 40, then 9 into 2, 18, minus 2, you will get 16, then 9 into 1, 9, plus 0, so you will get 9, correct? Now we are multiplying, also we are multiplying third row with minus 3 and add into the second row, so you will get 0, 0, 1, 0 here, correct? Now we are multiplying third row with minus 3, so minus 3 into minus 5, 15 minus 2, you will get 13, then minus 3 into 2, minus 6 plus 1, you will get minus 5, and then minus 3 into 1, that is minus 3 plus 0, minus 3. So the second row is now 0, 1, 0, 13, minus 5, minus 3. Now you can see left hand side, this is almost our identity matrix except this minus 1, okay, we want 1 here, so that's why we are multiplying minus 1 with the third row. So this is a correction, this is not a minus 1, this is 1, okay. So here is the correction, so mention it in third row, 0, 0, minus 0, 0, 1, 5, right, minus 2, minus 1. So now this is our inverse of the given matrix, minus 40, 16, 9, 13, minus 5, minus 3, 5, minus 2, minus 1. Okay, so this is our given matrix 1, 2, 3, 2, 5, 3, 1, 0, 8, and this is our inverse of the matrix, minus 40, 16, 9, 13, minus 5, minus 3, 5, minus 2, minus 1. Okay, if we want to check that our answer is correct or not, you have to multiply this matrix, our given matrix A, with A inverse, you will get definitely identity matrix, okay, right. So A into A inverse, that is identity matrix. So here is our answer, A inverse, that is equal to minus 40, 16, 9, 13, minus 5, minus 3, 5, minus 2, minus 1. Next question, question 2c. Determine whether the set of all polynomials a0 plus a1x plus a2x square plus a3x cube for which a0, a1, a2, a3 are integers is a subspace of P3. Now P3 means set of third degree polynomial, and we know that the dimension of P3 is equal to 4. In general, dimension of Pn, that is n plus 1, where Pn is the set of polynomial with n degree. Okay, so dimension of Pn is equal to n plus 1. Now here is our question is that determine whether the set of all polynomial a0 plus a1x plus a2x square plus a3x cube, where a0, a1, a2, a3, that means all the coefficients are integers. Is it correct that this is a subspace? And our answer is no. This set is not a subspace, because what is the definition of subspace? There is a two conditions. First of all, if W is a set of, if W is a subset of, first of all subset, right? If W is a subset of vector space V, what are the two conditions to become a subspace of subspace for the W, right? The first condition is if UV belongs to W, that means any two elements which is from the set W, the addition of that two element U plus V, that is also belongs to W. That is the condition. And the next is if alpha into U, that means the scalar multiplication alpha into U, that is also belongs to W. If these two conditions are satisfied, then we can say that our set is a subspace. But here what happened, if we take Px and Qx are two elements from the set, right, where ai, bi are integers, all the coefficients a0, a1, a2, a3 and b0, b1, b2, b3 are integers. But the first condition first condition definitely satisfied, that Px, Qx, that is also belongs to the set, because a0, b0 are integers, so definitely a0 plus b0 also integers, a1 plus b1 also integers, similarly a2 plus b2 and a3 plus b3, that all are integers. That is correct. But the scalar multiplication, the second condition drop here, alpha into Px, where alpha is scalar.